Now that we've looked at triangles, the types of triangles we have, and proving them congruent, we're going to move into right triangles. So to begin with, we're going to start with the Pythagorean Theorem, which you've seen before. But first, what's a right triangle? Well, it's a triangle that has one right angle. And remember, we can only have one right angle because our angles have to add up to 180 degrees. And the two sides that make the right angle are called the legs. Okay, so the ones that touch that right angle are the legs. The side that's opposite the right angle is our hypotenuse, and it's always the longest side. Remember, there's a relationship between our angles and our sides, and whenever we have a right triangle, that 90-degree angle is the biggest angle, which means the side opposite has to be the biggest side. And we call that the hypotenuse. So the Pythagorean theorem is not just this equation a squared plus b squared equals c squared. The Pythagorean theorem says if a triangle is a right triangle, then a squared plus b squared equals c squared. So if I'm told it's a right triangle, or if it's labeled with that box in the angle, I know it's a right triangle, I can plug in my sides to a squared plus b squared equals c squared. And remember, the c always has to be your hypotenuse. Okay, so for example, if I said that we have sides of 10 and 26, and I want to find this side over here. Well, I might call this side b and say 10 squared plus b squared equals 26 squared. Well, 10 squared is 100. So we have 100 plus b squared equals, and then 26 squared is 676. Subtract my 100, I get b squared equals 576. Square root to cancel out the square, and we end up with b equals 24. Alright, so you just plug in what you know, making sure that your hypotenuse is always the c, right? And my right angle is right there. Okay, we have something called Pythagorean triples, which is just common side lengths of right triangles that work nicely in the formula. So if you recognize a Pythagorean triple, you don't even have to think about plugging it in. You just think about how the sides relate to each other. Some common ones are 3, 4, and 5, 5, 12, 13, 7, 24, 25. There's another one down here that got cut off, and that one is 8, 15, 17. Now, it's not just these 3 or 4 sets, it's any ratio of these 4. So for example, 30, 40, 50. Right, I took all of those sides and times them by 10. 30, 40, 50 is going to form a right triangle. So if you see 30 and 40, you know that it's got to be a 50 to finish out your 3. Okay, and likewise, if I took all of the third one, 7, 24, 25, and doubled it, I would have 14, 48, and 50. That's going to be a right triangle. So it's any ratio of these sides, which means it's these sides multiplied by the number, and all 3 sides are multiplied by the same number. We also have what we call the converse to the Pythagorean theorem. Okay, and remember the Pythagorean theorem says that if we know it's a right triangle, then we can use a squared plus b squared equals c squared. Well, the converse is the opposite, and it says that if I plug in my 3 sides, making sure that the longest side was c, and a squared plus b squared equals c squared, then I know it's a right triangle. So if I'm given 3 sides and I plug them in, and it all works out nicely and it's a true statement, then it must be a right triangle. So for example, if I were to have side lengths of 6, 8, and 10, right, 10 has to be my c, it's the longest side. So we have 6 squared plus 8 squared, and I want to know if that equals 10 squared. Well, 6 squared is 36, 8 squared is 64, 10 squared is 100, 36 plus 64 is 100, and 100 equals 100. So that means that this is a right triangle. And if you notice, this is also 3, 4, 5 times 2. So this is a Pythagorean triple. So if you had seen that to begin with, you would have known it was a right triangle. Now, if I plug something in and it's not equal to c squared, it means it's not a right triangle. Well, my only other options would be an acute triangle or an obtuse triangle. So we have the Pythagorean inequality theorem. And that says that if c squared is bigger, okay, when I plug everything in, if my c squared is bigger, then it's obtuse, right? And remember, obtuse means bigger than 90. So if we have a big c squared, we have a big angle, and it's obtuse. If c squared is smaller, then the triangle is acute. So remember, acute is less than 90, so if it's a smaller c squared, it's a smaller angle and it's acute. So for some examples, I want to determine if these triangles are right, obtuse, or acute. So I'm just going to plug them into a squared plus b squared, and I want to know how that relates to c squared. Alright, so if I plug in 6, 8, and 10, alright, 10 has to be my c, so I've got 6 squared plus 8 squared, and that has to relate to 10 squared, and this is one we just did. 6 squared is 36, 8 squared is 64, and 10 squared is 100. 36 and 64 is 100, so 100 equals 100. Because this is equal to, that means that it's got to be a right triangle. For the second one, 5, 12, and 12, if I plug that in, I've got 5 squared, and now 12 and 12 are both the biggest sides, so that just means one of them's got to be my c. So 5 squared plus 12 squared, I want to see how that relates to 12 squared. 5 squared is 25, 12 squared is 144, and then 12 squared again is 144, and then 25 and 144 is going to give me 169. Okay, so 169 is bigger than 144. Remember, it's all in relation to your c squared. So my c squared of 144 is smaller. So that means that my angle is smaller. So it's an acute triangle. And then for the last one, 7, 20, and 25. That 25 has to be my c squared. So we've got 7 squared plus 20 squared. I want to know how that relates to 25 squared. 7 squared is 49. 20 squared is 400. 25 squared is 625. 49 plus 400 gives me 449. And 449 is less than 625. So my c squared, 625, is bigger, which means that this is an obtuse triangle. It's a bigger angle. Alright, so we have the Pythagorean theorem that says if I know it's a right triangle, I can use a squared plus b squared equals c squared. The converse says that if I plug it in and a squared plus b squared does equal c squared, I know it's a right triangle. And then the inequality theorem goes even farther with that and says that if c squared is bigger, it's obtuse, and if c squared is smaller, it's acute.